if there's no questions on any of the homework assignments, we're going to go on and get started with today's lesson. And what we're looking at today and tomorrow is dealing with division of polynomial functions. What we're going to work with today is long division, and what we're going to do tomorrow is synthetic division. Now, before we start dividing polynomial functions, we're going to do a long division problem. Now, it's probably been quite some time since you've done dividing two numbers by long division, because at this point, if you're going to divide two numbers, you're just going to plug it into the calculator to get the answer. But we're going to do this here by long division because long division of two numbers and long division with polynomial functions are very similar in a lot of ways. So the first thing we're going to do in dividing these two numbers by long division is to put our first number inside here, and the number we're dividing by goes on the outside. Does anybody remember what we do next? Right, we would see how many times it goes into 2, which we know 13 does not go into 2, so we would look at 29. So how many times does 13 go into 29? 2 times, because we want to simplify, we want to eliminate and reduce this number inside 29,682 all the way down by 13s. And the first thing we can say is 13 goes into 29 2 times. Then we would do 2 times 13, and 2 times 13 would be 26. And then what did we do next? We would subtract. And 29 minus 26 is 3. Then our next step is 2. Bring down the 6. Yep, and then we repeat what we just did, because then we see how many times exactly 13 goes into 36, which is 2, because 3 would be 39, and 2 times 13 is 26. Then again, we would subtract. And 36 minus 26 is 10, and we would bring down the 8. Now we need to see how many times does 13 go into 108, which is 8. And again, we'll do 8 times 13. 104. We'll put it right underneath. Then again, we will subtract. And 108 minus 104 is 4. And last but not least, we bring down the 2. And what times 13? 3. So we'll do 3 times 13, which will be 39. And we would subtract, telling us that we have a remainder of 3. Now at this point here, with numbers, we can put a decimal and continue doing this until it either becomes 0 or we find a pattern or we just get tired of doing this. But if we wanted to write it as a remainder, we would write what over what? 3 over 13. The remainder over what we're dividing by. And really what we're doing here is trying to eliminate one term at a time out of 29,682 to reduce it down to see how many times 13 will go into it. And we're going to do a very similar thing with polynomials. Now, you don't have to write this down, this here. When you divide a polynomial function f of x by a non-zero polynomial divisor d of x, you get a quotient polynomial q of x and a remainder polynomial r of x. So when we divide two polynomial functions, we will get a quotient with a remainder over the divisor. So let's work this out. Now before we do the first one, you can go on and write that there at the bottom of that spot, because I want to do one that divides evenly first. So what we're going to take is x cubed plus 3x squared plus 3x plus 1 and divide this by x plus 1. This is going to be the first one that we do. So when we do this by long division, we're going to set this up almost like we did with the one with numbers. So we're going to have our little house. The name of this is completely out of my head right now. But we're going to put what we're dividing inside and put our divisor on the outside. So this is set up exactly, almost exactly as like what we just did with the two numbers. Now the main difference is going to occur here. Because what we want to do here is we want to eliminate this one term at a time until we can't do that anymore. So our first term inside is what? X to the third. We want to eliminate it first. And we're going to eliminate it with our x plus 1. So what we're going to ask ourselves and what we want to find is what times x gives me x to the third? What times x gives me x to the third? Yeah. What do y'all think? X squared, because x squared times x is x to the third, yes? So that's what we're going to do. We're going to do x squared times x plus 1 because we want to eliminate that x cubed first, and we're going to eliminate this one at a time. So the first thing we need to figure out was what times x gives us x to the third. Well, it's x squared. Now we want to multiply x squared times x is x to the third. X squared times 1 is plus x squared. And we're going to take that and put it right under here. Any questions on this so far? Does anybody have an idea of what we'll do next? We're going to subtract. X cubed minus x cubed is 0. We want those to cancel out. We want the first term for each one of this part to cancel out. Now let's look at the next one. 3x squared minus x squared is 2x squared. 3 minus 1 would be 2. And then what would we do next? We would drop down the plus 3x. Any questions on any of this here? We feel good with this so far? Now we're going to do that again. Because now we don't want to eliminate x cubed. X cubed is gone. Now we're wanting to eliminate what? 2x squared. So what we need to see is what times x will give me 2x squared plus 2x, a positive 2x. We'll get those to be the same. And we'll multiply it. So we'll do 2x times x plus 1. Two x times x is 2x squared. 2x times plus 1 is plus 2x. And then we will subtract. 2x squared minus 2x squared is 0. Those will cancel. 3x minus 2x is x. And then what do? We bring down the plus 1. And we do it again. Because now we need to see what times x gives me x. It would be plus what? 1. Let me go on and write that out because we can do 1 times x plus 1, which is just and then we would subtract. X minus x is 0, just like we wanted. 1 minus 1 is, so that gives us a remainder of 0. So it tells us it divides into it evenly. And our solution is this here. And that's it. Now, if y'all can kind of see, this does kind of mirror long division. It's a little different in some aspects because we don't have just solid numbers, but we do have terms. And the main goal is really to eliminate that first term each time till we can't go any further. Any questions on this here before we look at the next one? Okay. Let's look at the next one here. And I'm going to start adding green. So the first thing we need to do with long division is to set it up. So we draw our little house. Put the polynomial x cubed minus x squared minus 2x plus 8 on the inside, and our divisor x minus 1 on the outside. Now with any of these here, we need every single term. Now we have them here because inside the biggest one that we have is 3, because x to the third is the biggest variable, yes? And we need to start at 3, so we're starting at 3. Then the next one would be x squared, x, and our constant term. We have all of them, yes? If we are ever missing one, we do have to add it back in with a 0x to whatever power we need and fill in all the missing gaps. That goes for our divisor as well. We have them all here, so we can go on and start with the process of dividing. The first thing we need to figure out is what times our x will give us x to the third, because we need it to cancel out. It would be x squared, because x squared times x would give us x to the third. And we can do that multiplication over here. We can say x squared times x minus 1. And do our distributive. X squared times x is x to the third. X squared times negative 1 would be negative x squared. And then we would subtract. X cubed minus x cubed is 0. We want them to cancel out. We always want that first term to cancel out. And let's see what happens to the rest. Negative x squared minus negative x squared. Here the negative and negative would make a positive. So negative x squared plus x squared is 0. Well, those canceled out also. That's not a problem. We can move on to the next step, which would be to drop the negative 2x, yes? So how many terms do I have now that we're going to divide into next? 1, I just have the 2x, yes? How many terms do I have in the divisor? 2. Well, I can't do 2 terms into 1, can I? No. What we could have done is here, we could have written in this as 0 x squared and done it that way. Because what times x is 0x squared? 0x. We don't have to do this. Because what we can do instead is, well, different color. I'm using blue. Blue. Because how many terms do we have here? 1. How many do we need? I can just bring the next one down. Because if we think back to numbers, and this probably might be very vague because it's been a while, because if a number didn't divide into it evenly, one more. Because here when we started out with 2, well, did it 13 divide into 2 evenly? No, so what do? We move to the 29. If we're later on, we'll bring the next number down because we know it won't work. We'll put a 0. The same thing is true here. So now we need to see what times x gives us negative 2x. So what times x gives us negative 2x? Yeah, it would be negative 2. Because do we already have x to the first power? Well, yeah, x is already to the first power. We're just missing the negative 2. So we can do negative 2 times x minus 1. Now, negative 2 times x would be negative 2x. Well, that's what we wanted, yes? Negative 2 times negative 1 would be plus 2. Then what are we going to do? We're going to subtract. Negative 2x minus negative 2x is 0. 8 minus 2 is 6. Can we go any further? How many terms do I have left? 1, I have the 6. Do I have anything else I can pull down? No. And unlike with when we're dividing using long division with numbers, I can't just add a decimal place because we can't just add the terms. So this here is our remainder, and we do need it. So our answer had what? X squared minus 2, yes? Plus what over what? 6 over x minus 1. Because our remainder is 6, and what we've been dividing this by is x minus 1. And that there would be our answer. Any questions on any of this here? Not too bad? Tedious? Monotonous? Both? Let's do another one. Because I want to do this one for sure, and we can do at least one more if you all want. So, let's see here. So what goes inside? 2x to the 4th plus 3x to the 3rd. And then we'd have plus what? Not quite. What are our powers? We have 4, 3. Do we have an x squared? Plus 5x minus 1. We need them all. I need 5, 4, 3, 2, 1 in our constant term. So if there's ever one missing, we have to put it in. Now I'm not going to worry about x to the 5th because it's in front of 2x to the 4th. But whatever power is the biggest one that we start with, we need it and everything going down to 0, going to our constant term. And that's true for inside as well as outside. So outside is x squared, 3x plus 2. We have them all. Any questions on this here so far? Okay. To start off with, we're looking at what times x squared will give me 2x to the 4th. So what number do we have in front of x squared? 1. So what times 1 is 2? 2. What times x squared is x to the 4th? X squared. So 2x squared times x squared would be 2x to the 4th. Then off to the side we can do 2x squared times x squared plus 3x plus 2. And you would. So 2x squared times x squared is 2x to the 4th. 2x squared times 3x is plus 6x cubed, and 2x squared times 2 is plus 4x squared. And we put it underneath, so 2x to the 4th plus 6x cubed plus 4x squared. And our next step would be to subtract. 2x to the 4th minus 2x to the 4th is 0, like we wanted it to be. 3x cubed minus 6x cubed is negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. And then we drop the plus 5x. Now, if you notice here, because we did have an x squared term when we subtracted, yes, that's why we need that 0x squared. We need something to hold that place so we get our subtraction. Okay. Any other questions on this here? Ready for us to do it again? So what times x squared is negative 3x cubed? Negative 3x. So we're going to do, you can do this off to the side, is negative 3x times x squared plus 3x plus 2. And negative 3x times x squared is negative 3x to the 3rd, like we wanted. Negative 3x times 3x is minus 9x squared. And negative 3x times 2 is negative 6x. And well, we will subtract again. Negative 3x cubed minus negative 3x cubed is 0, because the negative and negative would make a positive. So negative 3 plus 0 is negative 3 plus 3 is 0. Now we can look at the next one. Negative 4x squared minus negative 9x squared. Well, here the negative and negative would make a positive. So negative 4 plus 9 is 5x squared. And lastly, 5 minus negative 6x, so 5x plus 6x is plus 11x. And last but not least, we would bring down the negative 1. And our last step, because we don't have any more numbers to bring down after this, what times x squared is 5x squared? Plus 5. So we're going to do 5. times x squared plus 3x plus 2, which would give us 5x squared plus 15x plus 10. And we would subtract. 5x squared minus 5x squared is 0. We would do 11x minus 15x, which is negative 4x. And negative 1 minus 10 is negative 11. Well, how many terms do we have left? 2. How many are we dividing by? 3. We are done. We can't do this anymore. Another way that we can see it is when we can't bring any other numbers down, and the degree of what we have here is less than the degree of what we're dividing by. Because what are we dividing by as degree? It is 2, yes? Because we have an x squared. The degree of this is 1. So we're done. This would be the remainder. So our answer would be 2x squared minus 3x plus 5 plus minus 11 over x plus 2 would be this whole thing here. We need the remainder. Now, another way that we could write this is if we took the negative out of 4x minus 11, we factored it out and moved it out front, we could write it as 2x squared minus 3x plus 5 minus 4x plus 11 over x squared plus 3x plus 2. I mean, we could write it in either way. And it's not so much that both of those numbers and the remainder are negative. It's more that the first term of the remainder is negative. It makes it look a little funny, but I'll take it in either form. Any questions on this here? Y'all want to see another example with? So before we officially finish this here, go on and look through the rest of the examples and see if there's one of those that you find tricky or would like to see worked out. If not, because all of them are going to behave the same way. And we just would need to fill in any missing gaps with plus 0x. And that is it. Fortunately, I don't remember the page number off the top of my head. And that is it. And that's your assignment.